To another lesson for chemistry. We're looking at unit conversion, dimensional analysis, factor label. All right, all of those are terms that we can use this process, and its definition is a means of converting between units while maintaining the same value. So we're just going to convert the unit, but making sure the number remains the same. All right, now the process we're going to do. First step, we want to put the given over 1. Identify all the equalities needed to convert from the given unit to desired unit. Make a fraction, a converter, to get out of the unit and into the unit you desire. Continue the process until you are in the desired unit. Multiply, and then remember your sig figs. And again, I'm going too fast, pause it, and be able to record your information. All right, now there are 3 specific converters we're going to use between English and metric. 1 inch is 2.54 centimeters, 1 liter is 1.06 quarts, and 1 pound is 454 grams. I know there are other conversions, but I'm going to require these so that we all do the same process. All right, so let's look at a couple problems. 766.400 milligrams is 1 ounce. Now, I did say the second step was to do the equalities, but I forgot when I set this up. So our equalities, milligrams, 1,000 milligrams is a gram, and 1 pound is 16 ounces, and 454 grams is 1 pound. Now we go back to the first step, take our given information, 766.400 milligrams, put it over 1. Now, we're going to take the first equation, which were in milligrams, so we're going to use multiply this one up here, and we're going to take it so that if we take and divide both of these sides by 1,000 milligrams. 1,000 milligrams over 1,000 milligrams is 1. So this basically is 1. It's not going to change my number, just change the value of the number. And we do that so that my milligrams cross out, and the unit that we want is in the numerator. All right, we're going to continue this process, multiplication, for the other 2 steps. So we're going to go from grams to pounds, and pounds to ounces, and everything crosses out. When we multiply through, we multiply across 766.400 times, we don't multiply by 1, so times 16, equals, divide by 1,000, equal, divide by 454, equal, we get a number on my calculator, 0.027009692 grams. Now, sig figs, I have 6 sig figs, so I have to have 6 sig figs as my answer. Remember that first 0 is just a placeholder. So 1, 2, 3, 4, 5, 6. That number afterwards is 5 or greater, so rounds up, becomes 7 grams. That's my answer. So we're going to look at this following problem, and that's my answer. Okay? And whenever you see that star, we're going to do this one later. So just copy this down. We'll do this in class. All right, now, we're going to go from there to something called scientific notation. Scientific notation is defined as way of expressing very large or very small number as a coefficient in a power of 10. Now the steps. First of all, you want to take a base number between 1 and 9.999. Can't be 10, can't be 2 decimals. Place a multiple sign and 10. If the number is a decimal, make the number of places moved a negative. If it's a numerator greater than 10, make it positive. And remember sig figs. All right, so let's take our first example. 1, 2, 0, 2, and 1, 2, 3, 4, 5, 6, 7 zeros. Okay, so that base number, remember, it has to be 1 and 9.999, so that's going to be 1.202, and our sig figs, we have 4 sig figs and 4 sig figs. Good to go. Times 10. Now, how many places do we move it? We're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's not a decimal, factor greater than 10, times 10 to the 10th. That's how we write it. Now, that's our answer. Okay, we take this number now, copy this down, we'll do this in class. Alrighty. Now there's 3 problems. We'll do these in class as well. Please copy them down. All right, and any questions, let me know. Hopefully this wasn't too bad. Take care, be good. Bye.